Here are some more properties that we're going to have to know and be able to use. This one says that if I have two logs that are equal to each other, and the base is the same, a and a in both cases, then I can write the arguments equal to each other. So if I have log base a of x is equal to log base a of y, then that means that x and y must be the same. I have another property here that says that the log base a of a product, x times y, is equal to a sum of logs, log base a of x plus log base a of y. The log of a quotient, log base a of x over y, is equal to a difference of logs, log base a of x minus log base a of y. And if I have the log of this argument raised to some power, I can pull that power down front. So log base a of x to the r is equal to r times the log base a of x. Now let's see if we can use some of these properties to solve for x here. I realize that I have 2 in the base in both of these log expressions on either side of the equal sign, but the problem is I don't quite have this situation here where I have a log equal to a log. I have 1/3 times the log equal to 2 times the log. Well, I might be able to take care of that using this property here. I've got this thing multiplied down here that could go up into the exponent. So we could write this as log base 2 of x to the 1/3 equal to log base 2 of 5 squared. Now I'm in this situation where I have a log equal to a log and the bases are the same. So what I can write then is x to the 1/3 is equal to 5 squared. Now to solve for x, I could just cube both sides. So now we would just have x. Remember when we raise a power to a power, we multiply exponents. So that's just going to be x to the 1 is equal to 5 to the 6th power, which is equal to 15,625. Let's see if we could do the same here. We have a minus here, but that's just the same as multiplying by a -1. So that -1 could go up in the exponent here on the 4 using this property. Same thing with the 2 on the x. So we could write log base 2 of x squared is equal to log base 2 of 4 to the -1. Now we can use this property here that says if we have two logs that are equal to each other and the bases are the same, then we can equate the arguments. So we have x squared equals, and I'm going to write this as 1/4. Now if I square root both sides, I'll have the square root of x squared is equal to the square root of 1/4. And remember, we don't worry about the negative here if it causes us to have the log of a negative value, which this one will. We'll have x equals plus or minus 1/2, and we'll disregard the minus because we can't have the log of a negative value.